By the end of this video, you'll gain a deep understanding of how to calculate quantum numbers. Have you ever wondered how scientists pinpoint the exact location and energy of an electron in an atom? That's where quantum numbers come into play. Today, we're diving into this fundamental concept in quantum mechanics. Quantum numbers are essential for describing the unique quantum state of an electron. They come in four types: principal N, azimuthal L, magnetic M_L, and spin M_S. These numbers work together to provide a complete picture of an electron's position and energy within an atom. First, let's start with the principal quantum number N. It indicates the main energy level, or shell of an electron, and can take any positive integer value 1, 2, 3, etc. The higher the value of N, the further the electron is from the nucleus, and the higher its energy level. Next, the azimuthal quantum number L, also known as the angular momentum quantum number, defines the shape of the orbital. It ranges from 0 to m1. For example, if n equals 3, then L can be 0, 1, or 2. These values correspond to different orbital shapes: S0, P1, D2, and F3. The magnetic quantum number M_L specifies the orientation of the orbital in space. It ranges from L to plus L. For instance, if L equals 1, M_L can be -1, 0, or +1. Representing the three different orientations of a p orbital. Finally, the spin quantum number M_S indicates the spin direction of the electron, which can be either +1/2 or -1/2. This property is crucial for understanding the magnetic properties of atoms and the Pauli exclusion principle, which states that no two electrons can have the same set of quantum numbers in an atom. Your support fuels my passion for creating valuable health and fitness content. Hit that like button and subscribe to keep the motivation going and unlock more inspiring videos, just like this one. Imagine you're in a library, and each book represents an electron. The principal quantum number N tells you the floor where the book is located. The azimuthal quantum number L specifies the section on that floor, while the magnetic quantum number M_L pinpoints the exact shelf. Lastly, the spin quantum number M_S indicates whether the book is on the left or right side of the shelf. Let's go through a quick example. Consider an electron with the following quantum numbers: N equals 2, L equals 1, M_L equals 0, and M_S equals +1/2. This electron is in the second energy level, in a p orbital L equals 1, with a specific orientation M_L equals 0, and has an upward spin, or _S equals +1/2. Thank you for watching. If you found this video helpful, please give it a thumbs up, subscribe to the channel, and leave a comment below with your thoughts or questions. Stay tuned for more insightful content on physics and beyond. Happy learning!